So here we have a parabola with a horizontal translation 1 to the right and then 3 up. As a result, we have a vertex right here at 1, 3. Right now, that parabola doesn't pass the horizontal line test. So if you were to reflect it over the line y equals x, or do the inverse, the result would be something that doesn't pass the vertical line test. Our inverse image would not be a function. This question is asking determine 2 different ways that you could restrict it so that it would be a function. So just like we saw in our example before, with our parabola, if we want that parabola to pass the horizontal line test, we'd have to consider only half of it, either the left half or the right half. So I'm going to color code things here. I'm going to start by highlighting this half in green. So if I only considered that half, how am I restricting my domain on the green part? What are the x values of that highlighted part? X is greater than or equal to 1. And again, our vertex is kind of telling us, because our vertex starts at 1, 3. If we considered everything bigger than or equal to 1, that would be that highlighted green part. If I want to see where does that graph end up, because it says we're going to want to write the equation and we're going to want to use the graph to illustrate. So I'm going to start with using the graph to illustrate. 1, 3, that's going to switch over here to 3, 1. Another point on this green side would be 2, 4, so that would switch to 4, 2. If you wanted to choose another point, we've got 3, 7, so I could go to 7, 3. Is that right? 3, 7. 4. Oh, my 4, 2 is in the wrong spot. And my 1, 3 is, now I knew something felt a little wrong. Here we go. 3, 1 would be right there, right? 4, 2 would be right there. 7, 3 would be right there. And so that would be the image or the inverse function for only that half. So if we restricted the domain to x is bigger than or equal to 1, which is only the highlighted green part, when we switch the x and the y values, the graph that we get passes the vertical line test and is a function. Now it says we also want to find out the equation for that graph. So I'm going to do some work off to the side here. If we want to find an equation of an inverse, algebraic, we've learned we switch the x and the y. So if I start with that, I would get x equals y minus 1 squared plus 3. And if I wanted to solve for y, I'd have to subtract 3 on both sides, square root, and whenever you square root both sides, you're going to have to remember the plus or minus. Oops.
You don't need to do it on the y minus 1 squared.
X minus 3. You just do it on the one side. You're right. And then finally, we can get y by itself by adding 1 to both sides. Now this creates 2 equations. One equation is the positive one, x minus 3 plus 1. The other equation would be with the negative out in front, negative square root x minus 3 plus 1. So that plus or minus in front of the square root means there's 2 options. One option's with positive, the other option's with negative. And sometimes it's easier to see things if we do in fact write both of those options out separately. Now, for our green graph, when we only choose half of our graph, our equation that we get is going to only be one of those 2. Can you tell if it's going to be the positive one or the negative one? It's going to be the positive one. And if we think about our transformations, does this make sense? Have we taken a square root graph, moved it 3 to the right and 1 up? Does that match with our green graph? Yes. So our first way that we could restrict the domain is to only look at the x values bigger than 1, which is the highlighted green part, and that would result in this equation for our inverse. It's said to create 2 ways. So for our second way, I'm going to highlight it again, but in a different color. Can you see that if you took this half on the blue side, when you just think about the blue side, it too would pass the horizontal line test. And you could restrict that one for x less than -1. You can write less than or less than and equals. It's fine. If you chose x less than or equal to -1, and you picked points on here, well, you'd still have 3, 1. Now we have 0, 4, so that would be 4, 0. And we have -1, 7, so that would be 7, -1. That would create the bottom part.
Less than or equal to 1, not
Right, thank you. X is less than or equal to +1. Our equation would be the -1. Does it make sense that that blue inverse graph is a square root graph that's been flipped over the x-axis, moved 3 to the right, and then 1 up? Okay, try some of these. Question 10 and 12.